My name is Huang, and I'm a PhD student of Plant Pathology Department here at UFIF's Tropical Research and Education Center. My research is about plant disease resistance and will focus on the evaluation of nicotinamide adenine dinucleotide, aka NAD, for the potential to manage powdery mildew on squash and halo blight on snap bean. Squash and snap bean are important economic crops in the United States, especially throughout the state of Florida. Snap bean is very popular in the market, and Miami-Dade County is both state and national leader in the production of fresh market snap beans. In 2019, Florida ranks first with snap bean production and third with squash. Same as snap bean. Florida also is the national leader for squash production. In this case, squash and snap bean production is crucial for Florida agricultural industry. But these two important crops are facing the challenge of diseases. Halo blight is a bacterial disease caused by Pseudomonas on snap bean. The principal management practices include cultural control by using resistance cultivar, crop rotation, and chemical control such as copper-based bactericides. But the resource of resistant cultivars are limited for the farmers. For chemical control, besides the concern of environment pollution and the cost, the pathogens can develop resistance rapidly. Powdery mildew is a fungal disease on squash. One of the aggressive pathogens is Podospora lancei, which is an obligate biotrophic parasite. For management, it also includes cultural control and chemical control. For resistant cultivar, squash has rare resources and no high-level resistance in the exceptions available. Fungicide application is still the principal practice, but with the negative effects on the environment, and it's expensive for farmers. The pathogen also can develop the resistance rapidly and limit the effectiveness of fungicides. For both disease, the current strategies are not effective enough, and with more challenges appearing due to the climate change, the alternatives for those disease management strategies is in demand. NAD stands for nicotinamide adenine dinucleotide. From single-cell organisms like bacteria to sophisticated multicellular ones, NAD is one of the most abundant and crucial molecules. Basically, without NAD, we would be on the fast track to death. You may have seen the advertisement for NAD supplements. Besides working in humans' body, it has been recently demonstrated that in plants, intracellular NAD can lead to extracellular and induce immune response, and the application of exogenous NAD can also induce immune response, which means NAD can work on disease resistance in plants. Under the condition that there is an urgent need of new strategies to manage those two diseases, and NAD has showed the potential in disease management, we want to see if NAD can be useful on disease management in snap bean and squash. For this study, we have four objectives. First is evaluate NAD for its effect on snap bean against halo blight and squash against powdery mildew. Then we want to improve the efficacy of NAD application. After the greenhouse study, we explored the mechanism of NAD function by RNA sequencing. Then we also had the extension project about screen and analyzed like RLK's family.
In the greenhouse, we tested NAD on soybean and squash plants. The results showed different application methods with 5 millimolar NAD can decrease disease in different levels. Leaf infiltration is effective on both plants with consistency, and for squash, soil drainage did not show effect. We also tested different concentration by spray and drench on soybean and spray on squash. When applied NAD at 2.5 millimolar on beans, the disease severity was significantly reduced. On squash, 2.5 millimolar was the threshold concentration that showed effect. Because foliar spray is the most common and practical application method, we want to see if there is any improvement for this application. Because surfactant is a common adjuvant, we tested surfactant Silvet and 220 combined with NAD. The combination of surfactant only lowers the disease level numerically, but we encourage to use it as an adjuvant. We also want to use fungicide and bactericide for the improvement. We didn't get lucky on fungicide on squash, but when we use copper-based coside, the half dose of coside rotate with the NAD can achieve same effect as full dosage. So NAD at 2.5 millimolar applied by spray improved the efficacy of half dosage of coside. So NAD at 2.5 millimolar applied by spray improved the efficacy of half dosage of coside against halo blight on soybean. In this study, we evaluated the potential of NAD working on disease management on vegetable crops. It also included the RNA sequencing study in order to understand the underlying mechanism. In the future, we will look for more improvement of practical use and a better formula for field trials.